Well, hello everybody, and welcome to our Mobile Viewpoint webinar, specifically on 5G, with a particular emphasis on 5G within the media space. By way of introduction, my name is Mark Andrews. I'm a global sales manager here at Mobile Viewpoint. And Michelle, would you like to introduce yourself?
Hi, I'm Michel Buys, Managing Director at Mobile Viewpoint, and here together with Mark host this presentation about 5G. So not about products, but purely about the technology.
That's the plan. And we have our very, very special guest starring this morning. Ian, would you like to introduce yourself?
Yeah, good morning. Thanks, Mark. I'm Ian Wagdin. I work for BBC R&D, and I've been looking at 5G for production use cases for around about 2 years now.
Excellent. So the plan this morning, I have a very, very short presentation. I'm not intending to talk for long. Ian is the expert here. I think most of us probably are aware of what 5G is and what it does. I thought I was a little bit of an expert on 5G, and I actually did a 5G quiz last night where I managed to get 1 out of 6 and didn't even know what a 5G triangle was. Perhaps, Ian, you might get the chance to explain more on that later. And the question I did get right was millimeter wave, whatever that means. But in any case, so in terms of housekeeping, by the way, everybody's on mute, so feel free to make as much noise as you like. But at the end, we intend to talk for about 20 minutes, the whole thing. And then the last 10 minutes, we invite you to submit questions. So within Zoom, there's a little Q&A box. Feel free to write some questions as we go along, or use the chat. That's fine as well. But to start with, I'm just going to kick off. I will share my screen. So the broadcast aspirations of 5G will be coming from Ian. I did ask him to talk about 5G, and he sort of said, well, I could talk about some of the aspirations. And for those of you who don't know Ian, as well as working for the BBC, he's the chair of the EBU working group for 5G, so he really is an expert in this field. So what is 5G? Well, as I mentioned, I think we all are aware of 5G, but for us, it's a real enabler as and when it really gets delivered upon. We know it's starting to be rolled out in various countries around the world, and perhaps there's some argument about who is really deploying this in a way that really means 5G and not just enhanced 4G. But for us in the M&E space or the media entertainment space, for us and us as a company, you know, we will make a difference. And I have a slide on that as well. But things like 4K, higher video frame rates, AR immersion, these are all sort of buzzwords that are coming out as a consequence of 5G. And for us as a company, for those of you who don't know Mobile Viewpoint, so we're a company been around for the last 10 years, and we really specialize in live streaming for events such as outside broadcast. So for news production, sports production, live events, where traditionally perhaps people might have used satellite, we have a bonded 4G, 3G solution where we bond together multiple cellular networks. So instead of using satellite, we can now live stream over the mobile network. But the interesting thing about 5G is that we're starting to implement 5G modems within our units. And we see opening up a whole host of new opportunities. So again, traditionally it was HD, now we can do 4K, but also people who want to do multi-cam productions. So there's this whole thing about REME, which is to do with remote production. But the ability to have a single mobile encoder where potentially I can plug in up to 4 cameras, where traditionally in the past it would be 1 encoder, 1 camera. But in terms of remote as well, things like RCP control, tally control, that sort of thing as well. And obviously the advantages of remote production, we're seeing a lot of sports companies going into this sort of remote production thing. And why are they doing it? Well, primarily cost savings, but also where they have to send employees around the world, they have to travel a lot. So there's a bit of an impact on climate change as well, but also just quality of life. So these people who traditionally used to travel a lot can now obviously do remote production so they can actually spend time with their families more. Michelle, I don't know if there's anything you'd like to add.
No, I think that's a good point. With 5G or 4G, you can already do a lot, but with 5G, you get higher guarantees that it really is going to work, and really you can deliver wireless REME productions. Because today, most time, it's a bonding of wired and wireless, and the wireless is more a kind of backup.
Great. So that's probably enough from us. You're probably itching to hear more from Ian, our resident expert, what he has to say. So Ian, what I'm going to do now is I'm going to stop sharing my screen and hand over to you. I think you're still on mute, Ian. Ian, you're on mute.
You're absolutely right. And that's the joy of doing these things via the web, isn't it? And I've just quickly edited my PowerPoint now to include that triangle, so there will be some reference to it. But yeah, thanks for bringing me along today. Hang on, that's sharing the wrong thing. Hang on, let's just find the right share. This will teach me to edit my PowerPoint. There we go. Let's try.
I just made you host, Ian, so you should be able to.
Yeah, there we go. Right, hopefully you can see that one. So yes, so the first things first, really. What are the BBC doing with 5G? And as I said earlier, we've been looking at a whole bunch of things for around about the past 2 years, and we started off very much looking at distribution user cases and how we might use it to actually kind of reach our audiences. You know, the consumer market, people are going to be buying these devices now. They already are buying these devices, and we absolutely recognise that people are going to want new experiences. So we've worked very closely with the EBU and 3GPP and a couple of European projects to kind of define what the distribution model is for 5G. And that's led us into a kind of couple of test beds and trials. So we actually built, our R&D teams actually built a modem, which enables us to kind of distribute content over 5G. We've done a couple of trials, notably Rural First and down in Bath and Bristol, where we've been using 5G to reach communities that perhaps won't be the first to roll out from a commercial point of view. And then we've been looking at some things with AR and VR and kind of new audience experiences. And then about 2 years ago, we started looking at the challenges for production, and we've got that's mainly what I'm going to talk to you about here today. So firstly, kind of why 5G for production? Why do we think it's worth looking at? As Mark's already alluded to, I think connectivity is key. It's all of our workflows now kind of really rely on connectivity and being able to kind of move content around, and we'll do that in a number of ways. And 5G is one of those obvious ways that we need to look at. It'll lower costs. Obviously, any move to kind of commodity working it has the potential to lower costs if we do it right. It gives us the opportunity to cover more events because of that lower cost. You know, if we can use small bits of kit that we just deploy more flexibly, we can put those out on events that we perhaps can't afford, or there's no space to send a large scanner or an AV truck to. Remote production, as Mark's already alluded to, better use of resources. You can have teams doing kind of multiple things all at once. And I think one of the things that's going on in parallel, and we'll be really familiar with, is this kind of move to IP, and that's going to play a big part in what we do over the next few years. And because of that, you kind of naturally move into wireless IP, and the kind of wireless IP spaces are dominated by Wi-Fi 6 and 5G, and they're kind of complementary technologies. Sometimes they're held up as to kind of almost a VHS and beta. I think there's a little bit of that going on, but they do have kind of complementary elements, and things that will work for one should work for the other. So we're kind of exploring those in parallel. And then finally, spectrum's an issue, or could be an issue for us in a few years' time. So those of you who are familiar with spectrum will be aware that we have a lot of kit that sits in the same space that we currently use for distribution of content or in other radio spaces. And if we move to an IP distribution model, obviously that spectrum may get reallocated. And so we need to think about, well, what do we do with the kit that operates in that spectrum, or do we need to make a case to maintain some of that spectrum? And there's other bands of spectrum that are under threat as well, around C-band and some of the other things that we use. So we need to look at it from that point of view, either to migrate into the new world, or to kind of make an argument not to migrate. So yeah, quick overview of 5G and where we see it at. So it's part of a journey. It's not something that's going to deliver overnight. It's not something that is going to kind of all happening with a big bang. There's a lot of bits and pieces, and obviously Gartner, those of you familiar with the Gartner hype curve, emerging technologies for 2019, right at the end of 2019, 5G is right at the top of that hype curve. So we're right now at the kind of peak of inflated expectations, and we're just about to kind of plunge into the trough of disillusionment, and it will take some time before we kind of settle and we get it right and all that kind of stuff. But the important thing is that we're working with industry, so we're working with the EBU, the European Broadcasting Union, as Mark said. We're also working with the standards bodies, so 3GPP, and we'll come back to that. We're working with the telcos, we're working with universities, regulators, manufacturers, just to basically try and think about how we move forward in this space. And we've got some key interests out of any broadcast technology. So, the ones that are easy to identify are things like bandwidth and latency and quality of service. But then we've got new types of networks, non-public networks. We've got network slicing, the ability to have dedicated bits of those networks. And then how do we onboard our devices? As we move to IP, we've got things like timing. We've got what they call device-to-device communication, so without the need to have a network. And then there's this kind of whole piece coming along around kind of edge compute and the ability to do things sort of closer to where your devices are, rather than doing everything back in big data centers. And as I've already mentioned, the kind of integration with IP. Here it is, Mark, the triangle. It's a pretty common described way of kind of the benefits of 5G, and it essentially says that you've got enhanced mobile broadband, i.e. fast connectivity, you've got massive Internet of Things, which is lots of connections all at the same time, and you've got low latency, and all of the different user cases fit into this different triangle in kind of different places. But ultimately, if you look at what 5G is and you go online and you kind of look at a whole bunch of stuff, what you'll find is that there's some really complicated architectural diagrams out there. So I commissioned one of myself to kind of look at really what 5G is. And essentially, it's some user equipment. There's some radio elements. So there's some what they call new radio. That's the new bit that's in 5G. That then connects into what they call a core. And then that connects out to the outside world. So the radio bit is the bit that is currently what's available in kind of public rollouts of systems at the moment. The core is what's going to be coming over the next year, and the backhaul kind of already exists there. So at the moment, anything that you go out and you buy 5G from a commercial supplier, the chances are that the UE, or the user equipment, the phone, will have some 5G elements of it, but it's probably new radio. More often than not, it is a 5G downlink and a 4G uplink, and stuff like that. A lot of the radio antennas are being updated, and that's what enables networks to kind of badge their stuff as 5G, because they've put this new radio in. But a lot of the stuff in the core still has a long way to go, and is still reliant on older cores, the LTE, the 4G cores, in order to provide the data plane. So in order to look at that, I thought it'd be just helpful to kind of look at these services. So you've got the kind of where the radio is, and you've got the radio in the core, and then you kind of get into these low latency, high bandwidth, more secure links. And we're starting to now just explore those, and we'll see some of those become commercially available. And we're really just kind of crawling in that space rather than kind of up to speed as we are with the new radio stuff. Then when we get into what we want to do with microphones, with cameras, with kind of connected devices, we're exploring it. So we're just about start. I mean, it's a cross there between a kind of crawl and a cross and a tick. We're just kind of dipping our toes in the water in that space to kind of understand it. And we're seeing that the first products come to the market, but they're all kind of based on what we were doing with bonded cellular and stuff like that. So I think there's a move to take advantage of some of these new technologies. And then finally, this whole network of networks. So this kind of combination of what we do with low Earth orbit satellites, what we do with 5G, what we do with Wi-Fi 6, this kind of whole bit of stuff that needs to join together. And the thing about 5G is it's a release cycle. So there's a set of releases which have certain groups of technology in, and this is why we're in this kind of crawl, walk, run stuff. So the release 15 stuff, that was a lot of the new radio stuff. Release 16 has things like UR, LLC, ultra reliable low latency communications, and some of those things. And then release 17 has a lot of the media use cases that I'll come on to talk about. But ultimately, what we think we'll get from this, what we want is mobility. We want the ability to kind of go to places that we've been unable to do broadcasts from before, whether that's live from a train or from a car or whatever. When I say unable to, I mean it's been difficult. Obviously, we've been able to do it with some of the bonded cellular kit, but there are challenges around that. We want the flexibility. We want to be able to kind of go out and deploy kit almost on an ad hoc basis, and we need the reliability that we expect from our kind of broadcast solutions. It's some of the, where we're currently on best effort networks, or we're reliant on elements of sort of LTE backhaul and stuff like that. It's very easy to fall off air, and we'll come back to that in a bit. So what have we been doing? First things first, working with the EBU and working on the standards. So there's a group called 3GPP. Many of you will be familiar with it. Effectively, they are the guys who look after the mobile telecommunication standards. And what's happened over with 5G, particularly over 4G, is that they've reached out to what they call the verticals. So these are the industries who are going to use this technology. And they've kind of opened the doors and said, right, we'll come in. Previously, up till kind of 4G, these things were really owned by the telcos and the equipment manufacturers, the large equipment manufacturers. So they kind of set the standards and all that. But for 5G, they reached out to the verticals and said, okay, well, what do you want to use these technologies for? What do you want to do with them? So a number of verticals. So obviously media and broadcast, but obviously emergency services, driverless cars, smart railways, smart factories, medical have all been kind of feeding in a whole bunch of standards into here. And it's worth just kind of talking about how 5G operates. So they look at, 3GPP operates. They look at what they call the RAN groups, the radio access network groups, and there's a whole bunch of groups within there who do some specification, and then that falls out into architecture. You've got the core networks and terminals, and then you've got the kind of systems, service and systems architecture. And effectively, the way into this group is almost via the kind of SA1 over there on the right hand side, where you've got this systems and use cases. And you go in and you write some materials, and you write some use cases, and then that comes out. So this is the what we call the. Oh, we'll just go back. Sorry. This is the specification. So on the left, this is a document that we wrote. For some reason, that's not working. There we go. So on the left is a document that we wrote, which is basically a very long document that defines everything that we want from a 5G system. Now, it's written for the telecommunications industry, and it's written to tease out requirements that are not going to be delivered if we did nothing. So you won't find in there things like file transfer or use cases like that, because they will happen anyway. What we're really looking at here is the kind of push user cases, and the push user cases are things like true remote production, things like timing, things like the kind of absolute measurements of what we want for latency and things like onboarding and things like radio mic latency and all that kind of stuff. And you write all that and you describe it, and then on the right-hand side, you actually issue a set of specifications. So what are those user cases? Single source contribution. This is kind of where we are now. You guys on the call and the Mobile Viewpoint guys will be absolutely very familiar with this. This is the kind of core user case that we have from bonded cellular. This is probably quite highly compressed. It's great for news, lower tier sports, but the problem is it's best efforts. It has a relatively high latency. It's reliant on multiple SIM cards, but it has moved us on, and it's moved us on quite significantly in the industry on how we cover live events, and it's shown us the potential for doing things over mobile networks. But we think you can do more. So we're starting to look at remote production. We're starting to look at remote production for higher tier events, and the difference really between some of these kind of areas where you might use proper radio cameras versus a bonded cellular solution is that you've got control over the solution. You know what the bandwidth is. You know that somebody's not going to pick up their phone and go on Facebook or Instagram and take you off air. And so you have that. And you also have a quality of service metric within those kind of COFDM transmitter solutions. And you can tune the network very importantly. So you can start to think about the network and tuning it for uplink versus downlink. And that then enables you to kind of move up to the the higher tier events, the tier 1, tier 2. This won't happen tomorrow, but as we say, kind of looking at radio cameras in that space. And then there are other elements. So one of the key things to do with remote production is timing. So if you've got multiple sources, you need to make sure that you can cut them together within a certain time frame. And yes, you can do that by putting out local kit at the far end and synchronizing it and all that kind of stuff. But wouldn't it be nice if the timing signals moved from, were just ubiquitous in the solution. And then you're starting to think about things like immersive and new storytelling from free viewpoint video. And what we really need those use cases to do, we need it to be reliable. We need that quality of service to be absolutely up there and better than we have now for things like radio cameras. We need better control over the latency. I quite often kind of say, when people kind of say, well, what do you want? Then low latency is obviously one of the first things they talk about. But low latency is great, but actually fixed latency is better. So if everything's working at 10 milliseconds and all my cameras are working at 10 milliseconds, or all my microphones, I can work with that. I can engineer my way out of that. If it's working at 1 to 5 milliseconds and it's constantly drifting, or probably higher because you'd start to notice it if it's higher, then you've got a problem. It's really a lot harder to kind of manage that, where you've got one or two devices that just aren't synced together and all that kind of stuff. So we're trying to kind of think about that. Bandwidth. We're talking some quite high bandwidth applications here. So we're talking up to 4K. So maybe somewhere in the region of 200 megabits per second uplink. But that uplink is critical, and most networks are tuned for downlink rather than uplink for obvious reasons. And then things like timing, we've already talked about synchronization, but timestamps for IP workflows are also something we see the 5G system as providing. And that might be one of the really early benefits. Currently, if you want to deploy an IP solution, you've got to have GPS timing and all that kind of stuff. But actually, if we can get that from the network, that might be better. And then finally, onboarding, non-public network slices. How do we manage these solutions within our environments? And we also want it to be network agnostic. I've mentioned that 5G is not the only game in town, so it's more about the workflows. So where are we with that? Coming back to our crawl, walk, run, absolutely out there with kind of mobile phones and kind of single camera things. Depending on where your life is, some of you will be up and running with that a lot more than others. Getting into multi-cameras, we're starting to see that, as Mark said, we're starting to see the products arrive on the market that enable kind of full multi-camera remote production. But there's a long way to go on that. Cloud-based workflows, those are going to really hit us over the next few years. And then truly connected devices, so microphones that are absolutely have 5G at their core and are almost as common as radio mics now. And then finally, some of these kind of larger user cases where we put mobile transmitters in helicopters and cover the Tour de France. And of course, all of that over the radio network. So where are we? This is a very busy slide, don't worry about it too much, but the important thing is that it's actually slipped slightly now because of the current work frame. So we'll see release 17 hit at 2022, and what's in release 17 is all of the stuff around the media use cases and specifications that we've got there. What we'll see first is release 17, and what that really gives us is that upgrade to the core that I talked about earlier. Some of the ultra reliable, low latency communication ideas, more efficient networks, better performing networks, the ability to slice and things like that. And the current system is just really starting to see these solutions come in. So we've been trying it out. This is about a year ago. It's a piece we did for BBC News. Basically, EE in the UK launched a network. It was the first public network that became available. So we went out to do some stuff with Breakfast News, and we took a WMT encoder, and we plugged it into one of these boxes on the left, which is it's essentially a box that takes the 5G in and spits out Wi-Fi or Ethernet. So we connected in via Ethernet and did some testing, and we got some pretty good results. We got kind of 50 megabits upload, 90 megabits download, all pretty good, looking quite attractive in that space. And that's from a single SIM. So that's from a single connection. So lots of potential there. And then just before we went on air, we get this message come up, and we learned a lot from this because, number one, we didn't have a computer connected to this device. It was just a camera on the into the WMT, and if you don't have a computer connected to whatever you're looking at, you may not see these messages. And basically what this meant was you've hit a limit, can you turn it off and turn it back on again? But we got there, we went live. How are we doing for time, Mark? I can show you what we did.
Yeah, it's all good, Ian. Carry on. It's fine. Yeah. It's interesting.
Can you hear that, or do I need to enable some sort of fancy sound?
Can hear it slightly, perhaps a little louder.
Okay, let me see if I can just do.
Go.
No, that's fine. It will have done. I'm just going to change the audio settings. Sorry, I should have done this beforehand. We go back, and now my computer's completely gone doolally. Right. Hang on, just stop sharing that. Right. Let's go back and share that. And then we're going to do that, and we're going to share computer sound. There we go.
Our users to download entire films in seconds is being switched on today.
EE is starting the service in 6 major UK cities, with 10 more locations due to come online by the end of the year. So let's go to our technology correspondent, Rory Catherine-Jones. Is in London's Covent Garden for us right now. Explain for us, Rory. I see you have phone poised, ready to go.
Yeah, but what's important here, Charlie, is this is a historic moment because we're actually coming to you over a 5G network. I don't know what the picture's like, whether I blur when I move around. I think it's probably pretty pin sharp, and I also think there's very little delay because we're all coming to you via a little box of tricks on a van a few yards away, which turns this into a 5G network going a 5G signal going over this new network. I've also been trying out the service with this phone, 260 megabits, quite impressive. Walk a bit that way, it might be higher, walk a bit that way, and it might be lower. But here's the funny, ironic thing. We were supposed to be doing this live broadcast about 15 minutes ago, and the whole system went down. Turned out we'd run out of data on the SIM card inside our box of tricks, and that goes to show just how much data you might be chewing up with one of these new 5G phones when and if they get to you. Because don't forget, it's fairly patchy at the moment, just in 6 cities. Vodafone will be coming along with their service in July, but the whole of the country, getting into all those parts that say we can't even get 4G, let alone 5G, that's going to take probably 3 years.
So you can see there, pretty stable solution. The bit about running out of data was to be fair to EE, was we didn't actually run out of data. There was it was a business plan, and it had I think it was a 10 gig cap on it, and you basically had to start it, which is why we got that message. And it worked really well, and the guys were really keen and happy to do that. I think we also did the first radio broadcast into BBC Scotland over a 5G network, and we carried on doing some stuff during the day. And once more, I've lost my mouse pointer on PowerPoint for some bizarre reason, and so I'm going to try and play you what happened on the 1 o'clock news, because I think it's quite interesting to see what happened there. Let's go to that.
Well, our correspondent Sarah Walton is at Covent Garden in central London, where folks have now been accessing 5G. No snafus, no problems so far?
Well, hopefully not, and I do hope you're hearing us loud and clear, because we are broadcasting over the 5G. The BBC has today become the first British broadcaster to go live using a commercial 5G internet connection. If we are breaking it, though, that may be because, as you heard in Rory's report, the coverage is still at the moment a little bit patchy. Just to demonstrate, This is a 5G enabled phone. It's connected to the EE network here in the centre of London, and we're actually only getting a speed of 40 megabits per second. Now that's the equivalent of what you would get off your home internet connection. But EE says in their testing they've been getting speeds of up to 800 megabits per second. Now if we all started getting that on our mobile phones, what it means is that the sort of things we do all day long on our phones, streaming music, downloading TV programs and films, and putting photos on social media, we could do that almost instantaneously. So still only available in a few places at the moment, but it's going to be...
Okay, Sarah, I'm going to have to interrupt you there because bizarrely the 5G line isn't working properly. So apologies to our viewers for that.
So there you go. There are some challenges, and the reason that happened, and the great learning for us was, one of those big promises we talked about right at the beginning is the kind of ability for more people to connect to the solution to 5G. So you kind of think about it. You think, oh well, we'll go somewhere busy. So we went to Covent Garden, and of course, 8 o'clock in the morning, pretty quiet. Come lunchtime, a whole bunch of people kind of turn up and are Instagramming their lunches over the network. And you're thinking, okay, well, we're 5G, we're not on the same network as them. But the cautionary tale is you're still reliant on that LTE core. So all of the traffic is going through the kind of same pipe. And you're still in that best efforts bit. Now, the upshot of that is that we learned a lot. Our news teams are out there currently doing more tests and more work with these devices. But we've got this kind of cautionary approach to it a little bit more. So I'm just going to wrap up, just kind of talking about what's next, and this is probably quite important. So, as I say, there's a lot of issues, there's a lot of problems, there's a lot of places we want to go, there's a lot of technology we want to try out, and there's a lot of good things and a lot of benefits that we can get from this. So we're working quite closely with a number of partners. The key one where we're kind of working with Mobile Viewpoint a little bit is on an IBC Accelerator challenge, which is really focused on kind of short-term sprint type. What can we do with kind of current technology that's here, that's now, to try it out, to kind of understand the workflows and all that kind of stuff. So there's about 10 champions in this kind of 5G remote production space. We've divided it out into 4 working groups. We're specifically looking at non-public networks. So these are kind of 5G in a box solutions that are starting to become available. So these are, if you don't rely on building a legacy infrastructure, it's really easy to go out and buy a small cell, what they call a small cell, which is effectively looks like a Wi-Fi access point, and then there's a bit of core network, and then you can tune that. So you can tune the uplink versus the downlink. So you can say, actually, give me the bandwidth to do some stuff like that, and then you can put that in a Faraday cage or a studio, and you can start to build a pretty simple 5G network that you can then connect to and start to use to give you some wireless capabilities within a local area. So we're exploring that. We're exploring that from a regulatory point of view. We're exploring it from a technology point of view, from a vendor point of view, because we think there might be some potentials in how we do this. We're looking at architectures in general. So we've talked a little bit about slicing. That's the idea where you've got a kind of network and you can kind of cut across and give yourself some dedicated connectivity within that network. That's all possible, but we haven't kind of delved deeply into how that will work in reality. It's there as a kind of idea, but what are the business models? What are the if you've got a contract with one company, how and they haven't got coverage in another, how do you do the roaming and all that kind of stuff? Artificial intelligence, again, Mobile Viewpoint really big on this, but we're kind of looking at how you deploy kind of AI in. One of the features of the core is that you can put compute power in that core far closer to your front end. So, can we put some AI in there, and can we use that to actually do some of these kind of production tasks? And then finally, kind of looking at where the current kit is and what the use cases are around that kit. We're also involved in a big EU project with a number of companies, Ericsson, Nokia, Red Bee, Sennheiser, and what we're doing here is, this is slightly longer term, so this is kind of 2 to 3 years, and we're really looking here at some of those kind of stretch user cases. So wireless cameras in the studio, wireless cameras in the in kind of the types of steady cams you see running up and down the side of football pitches, how they kind of integrate in with things like 2110 and studio elements. And there's 3 bits of that. So Sennheiser very much looking at kind of how you might look at radio mics and audio production and the different elements that 5G might play in that. Some of that is, as you can imagine, absolutely very latency critical, and it will probably work on device to device or public networks. Don't think for that multiple microphones will connect over a public 5G network. That's not what we're thinking at all. We're also thinking of this kind of wireless studio type workflow, as I've mentioned, really integrating into our IP workflows. And then finally, what we call free viewpoint, which is this idea of having lots of cameras around something and doing a kind of video time slice. And the reason that this works is because you can kind of do that edge compute to do the rendering of those multiple devices to give you the free viewpoint video, and you can do mesh networking to connect those cameras together. So you don't need to kind of wire each camera individually. So you should have quite a big rig to do that. And then finally, with the EBU, the work continues to define the user cases, and we're also going to be publishing some guides coming up over the next couple of months. So the first one was actually published earlier this week. It's a report into the distribution of media for 5G. It's EBU Tech Report 054. For those of you who are interested in distribution of media content, it's well worth a read. And we're producing a similar one for the contribution of content. And as you can imagine, they are similar but different worlds. So with distribution, you're looking at territory-wide, big, universality of service. Whereas with production, we're looking at small, ad hoc, kind of easy to deploy solutions that need to cover everything from news up to a Eurovision Song Contest. So lots of challenges in doing that, and therefore we're writing these guides to kind of help sort of people understand that. That's about it from me. Just to say, we're also working, a couple of others, as a UK 5G Create call, which is another kind of test beds and trial. We're working with a group called 5G Mag, who are looking at the regulation, the kind of spectrum issues, and of course we're also working with the ITU on kind of what radio will look like beyond, I think the next conference for that, for World Radio Congress, which sets all the kind of spectrum things, is 2023. But we're actively kind of looking at that now to think about how we might use spectrum in the future. So that's it from me. Hopefully that made sense.
That's great, Ian. Yeah, thank you so much for that. That was very, very interesting. I wish I'd known that 5G triangle yesterday. I think I might have done better in the quiz. But one of the interesting things that come out of this, for us at least, we're a technology company, and obviously we've been doing bonding for the last 10 years. And now with the enablement of slicing within 5G, we have to sort of continually innovate and continually reinvent ourselves. And as Ian alluded to, we continue to reinvent. And over the last couple of years, we've come up with a few AI technologies as well. Given our broadcast experience, we're able to apply that, one being an automated studio production system, which actually we're using here to run the webinar, but also for sports production as well, automated sports production. And combining that with 5G live streaming, all of a sudden we have a very low cost solution for creating really professional sports productions. And perhaps the difference being, in the past this was not possible, whereas now we're really enabling sort of new viewing experiences that in the past, you just couldn't achieve on the budget that's expected in order to create these professional productions. So what we're going to do now is go to the Q&A session. So if you do have questions, please feel free to write some quick questions in there. We do have a couple of questions now, which I'm just going to click on. So the first one from Rune. Ian, would you contribute from cameras using single link 5G, so no bonding on public network? We wouldn't, due to the physics of the radio link. I don't know if you have a comment on that.
Yeah, so it really depends on what you're doing. So we saw the breakfast thing. that was a single link. We were very clear when we did that we were using the 5G network. We could have bonded that. We could have had a 4G. We could have had fiber underneath it. We could have had VSAT or a number of other solutions. But we were going over 5G. We told everyone we're going over 5G, so we weren't going to hide that. I think we'll see. The challenge there was not the radio link. The challenge was in the core and LTE. So I think it's possible, but it's absolutely down to your appetite for risk and also what you're transmitting over it. And this comes back to everything that I'm saying around actually different workflows will have different types of solutions. So if you're contributing to an online debate or broadcasting a council meeting that you wouldn't have otherwise have done, then a single 5G link over a public network, once these networks have become more reliable, more stable, then why not? But no, you're not going to broadcast something that you've paid millions of pounds for rights or is a flagship program over a single 5G link. Why would you? Even if we don't do that, we have redundant paths for fiber links and some of our best connectivity at the moment. So it really is kind of horses for courses. And I think the democratization of some of this stuff will mean that, yes, we will broadcast some things over single links, as we do with 4G at the moment.
Sure, and I think our approach is the same. Even with 5G, you might have the bandwidth and the low latency, but you still always want the inbuilt resilience and maybe multiple network providers. And even in 4G, which is stable, it's not uncommon every now and then for T-Mobile or one of the other ones just to fall down. And also they don't always reach into some places that the others do reach as well. So it's just having that resilience and ensuring you cover all your bases.
Yeah, I mean, the one of the answers to that is network slicing. The other one is deploy your own networks. And people kind of, when you talk about private networks and things like that, people immediately think that you're going to build a massive kind of Vodafone scale network. We're not talking that. We're talking kind of small cell type solutions. Those are in the UK certainly we've seen. Some moves to kind of how we might deploy that. I know certainly colleagues in the Nordics have access to spectrum where they can do that. We're exploring that in the UK, and because 5G is not reliant on, if you want to build a network, as I said, that you don't need to send SMSs over and you don't need to have LTE access to, then you can build yourself a relatively small network in the same way that you would with a diversity network or a mesh network for radio cameras and things like that. So I think there will be different ways of deploying this, and private networks are one of those. But we're just setting out on the journey to kind of test that.
Interesting. Let's move on to the next question from Tom. Yes, here in Antwerp, I get around 1 frame per second. I suppose this is due to Zoom and not 5G. Yeah, so when you were playing your video, Ian, it was a little blocky. The audio was fine. I'm assuming it's coming, maybe you're connected via Wi-Fi rather than 5G, and you don't have your own 5G network.
Yeah, I'm connected on my home.
Zoom in general is not very good at doing multimedia rendering. Like many times the video block or Higgs. The blocks in the second video were true, I think, in the original content.
Yeah, no, they were. Okay, sometimes it's better than others. It's always risky playing video. I think the other thing I've noted, actually, video plays better from this is a separate thing, but if you're going to play video, don't play it from PowerPoint.
Yeah, that's also a good point. Yes.
When I've done video on Zoom before, sometimes playing it in a separate player makes a lot of difference.
Yeah, that's true. I was going to suggest perhaps you could build your own 5G network, which kind of brings us on to the next question from Alan. Should we come to a conclusion that 5G normal use is not for the coming few years? I mean,
I think that,
when do you think this is going to be deployed?
So that completely depends on your use cases. So it will be absolutely normal use for news, and it's becoming. There's a number of organisations that are out there. There's bits of kit that are on the market, and people will start to use it as it becomes available. will it be the normal use where we've got at the moment better solutions in place? Well, probably not. But if we start to lose those better solutions, or we're looking at more cost-effective versions of those solutions, then it will get better. If you'd said to me 6 months ago, the normal way of conducting meetings would be over the internet, you'd kind of be going, oh yeah, but there's no, but these things accelerate and these things happen a lot more quickly. And so we're seeing, BT in the UK are doing a whole bunch of stuff with 4G connectivity just to kind of stay on air at the moment. So I think there are, this is a journey, and what we need to do is kind of set out where we want to go to with that journey, and then kind of get the stuff done on the way, and the early stuff to do will be the natural evolution. So the early stuff will be, moving from a 4G solution to a 5G solution, from a bonded solution to it may well be a bonded 5G solution. So that kind of space. But if we want to go further, and if we want to look at these things where we've got a very real threat from spectrum, or we want to reduce our costs and things like that, then we have to explore these other technologies. So I think if I'm going to put a timescale on it, it's always difficult, but it may, as I say, situations like the current one may well accelerate it a lot more. But yeah, I mean, we're looking probably 5 to 10 years before a lot of the kit becomes really available. But that's why we're doing the work we're doing now.
Yeah, makes sense. We have a next couple of questions from Steve. Welcome, Steve. Isn't the bottom line always the radio elements and access, the physics of RF? What are the key aspects of the new radio elements to improve on that?
Okay, so I'll come in here and say I'm not a spectrum expert by any shape or form, but there are if we go back to that triangle, there are a number of things that you can do to kind of improve the RF, and it's the little bits that kind of all add up. So in the radio spectrum, there's a couple of bits that are, or in the way the new radio works, there's a couple of bits that are fundamental to this. So one of them is that number one, it's a full duplex. For the first time over a mobile network, it's a full duplex network, which means that you can transmit and receive at the same time. Current solutions have kind of almost you don't notice it, but there's a kind of you broadcast some packets and receive others and all that kind of stuff. Then you get into this kind of massive multiple input, multiple output MIMO type solution, which are these antennas now that have an array of different antennas to give you far more focused radio access. And they use beamforming as well, so you can have far more connections into a single base station, and so you've got different radio elements of that, and then you get into the spectrum and the physics of spectrum, and we know that really well. We've been dealing, broadcasters, we've been dealing with spectrum for over 100 years. We kind of know what spectrum works well for what, and we know that millimeter wave won't go through buildings and won't go through glass, but actually will carry high bandwidth applications. So, if you've got line of sight transmitters within a studio environment, could you use that? We know that the kind of 700 megahertz bandwidth is going to probably is really good for kind of long distances and going through buildings, but it doesn't cover the bandwidth. So you probably might need to use more compression in that, and therefore it might be better for distribution or receiving of content. And then above that, there's also a whole bunch of stuff around software defining some of these things. So, can you tune the network or a slice of the network in order to deliver a more efficient use of that radio spectrum? And then there's a whole bunch of other things in the standards around dynamic spectrum sharing and all of that, which will go on to improve that. That's a really
in general,
quick gallop through.
The radio technology doesn't change; it's more everything around it.
Yeah. And it's the same with any technology. The fiber hasn't really changed that much since it was invented, but what we're pushing over it is better and better.
Yeah, right. Same thing. Yeah.
Same with broadband, of course.
Yeah. So on fiber we can do more.
And telly, we're broadcasting TV, HD TV. So.
Yeah.
Sure. I wish I knew about the full duplex. Actually, the full duplex question was in the quiz last night, so I think that was one I did get right. Next question from Steve again. Will the broadcast solution rely on SMPTE 2110? Are there any adjustments specific for 5G to be considered? Do you know?
Okay, another really good question, Steve. We're looking at, obviously 2110 is designed to be on a managed network, on a wired managed network. So there's a number of challenges between how you carry stuff in a radio solution to how you carry things over a fiber solution.
It's a smart one.
So we need to really think about that, and there's some work going on the SMPTE side to think about just WANs in general. But there are some core principles within the 2110 structure that we want to try and interface into. So things like the kind of timing, the PTP timing and identification for RTP packets, how you carry that stuff. But it's not the be all and end all. What we've been very clear with 5G and the standards is that we just want a bit pipe that we know what the quality of service is, and we can put whatever we want down that bit pipe. So you should then have, if you want to put high bandwidth uncompressed video down it, and you've got the capacity and the budgets and stuff to do it, then you should be able to do it. It shouldn't be a limitation of the network layer. That should be your choice at the application layer or above. And therefore, we've concentrated on things like quality of service, latency, bandwidth, and getting those timing signals rather than carrying specific media transport encoders, because they will change over time. And some people will want 2110, some will want NDI, some will want other solutions. And the other key thing is that, it's 2110 is very much kind of is very much the kind of workflow that you're going to have in a studio environment. And what we want to try and achieve is to have an open platform where it doesn't matter how you interface into. So you want devices that are going to present as 2110, even if they haven't been carried as 2110 over the networks. We want open standards. We want open workflows so that we can kind of not have to have dedicated transmitters and receivers that are proprietary and do specific things in order to, and therefore you have to have a one-to-one matching of kit. So the more we can harmonize those workflows, the better it is for everyone.
Sure. Next question, Constantine. Starlink versus 5G.
Yeah, I found it a smart question. I think there will be competition because Starlink is, of course, the network of Jeff Bezos, if I'm right. So he's launching many of these small satellites, offering broadband to the home via satellite at low delays as well. And also the pricing was mentioned on the internet is really low. So if you talk about competition for bandwidth, I think Starlink will be interesting. The only thing is always that you have to have sight to the satellite. So if you're in-house, it's not working, then you have to rely on 4G, 5G. But if you're outside, I think Starlink is a very interesting model, actually.
Yeah.
Also the pricing looks very promising.
I completely agree, but I think the thing that is going on at the moment, and the discussion points that are going on in the in particularly 3GPP, is actually this kind of always-on connectivity network of networks, and therefore, if you can, our requirements don't change. The bits we've defined are. Doesn't matter if I'm carrying them over a Wi-Fi network or a 5G network or over a Starlink network. There's a whole bunch of or other low Earth orbit solutions that may well become available, so there's a whole bunch of work going on at the moment to look at. Obviously, from maritime, from aviation, they're kind of all looking at how they might integrate mobile networks into satellite networks. So I think it will just become an extension of the same thing over time. But again, it's a few years away yet.
Sure, and in the past we've always built hybrid solutions: 3G, 4G, Wi-Fi, and satellite. So maybe we just have a hybrid to add to the resilience.
It's more that the satellite is always the most expensive part of the whole bonding, but promises for low cost. Okay.
Last question from Alan. Do we have new 5G modems on the roads for our devices?
Yes. Yes, as explained yesterday also in another webinar, is that we already ordered them from Share Wireless. And we're waiting for the first delivery of the first, they call it a beta batch. So you can test yourself as manufacturer if it all works fine. And at the moment, they are still certifying their modems with the standardization bodies and with the different operators in the world like Docomo and Verizon in the US. And then they expect to have later this year, September, October, to do mass production of the first 5G modems. And then we're also at that moment ready to install them in your devices, or actually perhaps sometimes you have to upgrade some hardware, different aerials. But yeah, we are waiting already for some time to start with it.
But I would caution against it slightly. It's all very well having the 5G in there if there's no network to use
yeah,
it on.
it is still patchy in the Netherlands as well. We have 5 very patchy, but of course it will automatically get better. So yeah, we are waiting for it as well. And as soon as we have it, you get it, because yeah, that's what we promised.
Yeah, I mean, I always warn against early deployment unless you're actually going to take advantage of the technology. There's no point having it just for the sake of having it.
No.
Yeah.
The devices are ready for it.
Excellent. Okay, Ian, I think we are done. Ian, have you got any last comments that you would like to add?
Oh, I can't think of any. Thanks for joining us. Reach out if you want to get involved in any of the work, or you got more questions, and we'll hopefully the key thing I think from here is that actually we've been approaching this both through the IBC and the EBU. We've been approaching this as a not as a single broadcaster solution. So kind of everyone is welcome to kind of contribute into this work, and it's really important that we've got a kind of view of the industry, because we are battling against the mobile networks operators, and we're battling against verticals such as the manufacturing industry and the medical industry and stuff like that. So we need to have an industry position, and that's one of the things that is been really quite nice about working on this project is the kind of collaboration that's gone into it. So
excellent. Michelle, any last words?
No, I just saw on short notice that Starlink is actually from not from Bezos but from Elon Musk.
Elon Musk, yes.
But they're both building a network, so we have choice.
Yes.
We can bond satellite.
Maybe multiple satellites.
Yeah.
Excellent. Well, on that note, someone's asking if the presentation is going to be available. What we will do, we'll just send a quick follow-up email to everyone afterwards, just with a link for that. If you do have any further questions, our email address is sales@mobileviewpoint.com, and then one of us will respond to you. But again, I would just like to thank everyone for joining us this morning. Big thanks to Ian for your time, for joining us. Been super, super insightful. We do appreciate that. And so all I can do now is wish everyone stay safe out there. Wish you well. And until next time, thanks very much and goodbye.